Alien life. There have been many theories, but precious little evidence. Now, dramatic new discoveries are pointing to intriguing possibilities. Powerful new telescopes, robotic rovers, and pioneering missions in space and here on Earth are providing tantalizing clues.
A whole new field has exploded into existence.
A host of newly discovered planets in space and life in extreme environments on Earth are forcing us to reevaluate our place in the cosmos.
It's an extraordinary moment in human history.
This is happening a lot more rapidly than I think people understand.
What's the scientific case for the existence of aliens? And should we be afraid?
The terrifying possibility is that the things out there are more like stormtroopers.
It's a dream that drives science fiction drama and a number of leading scientists involved in real space exploration. The moment that civilization on Earth realizes it is not alone. Having sent space probes and countless radio and television signals into space, one day, something will come back. Perhaps it'll be powerful laser signals that are finally received and answered. Alien intelligence sends a spaceship to investigate the signals received from the third planet around the sun. It would be the greatest, most shocking event in human history, a moment that would fundamentally change everything. It's a fantastic, often frightening science fiction story. But will we ever get an answer to the most compelling question in the cosmos?
What we all want to know is our kinship to other life forms elsewhere in the Milky Way galaxy. Are we alone, or are there brethren out there among the stars?
T-minus 10, 9, 8, 7.
Surprisingly, many experts now believe that intelligent creatures are really out there.
Ignition, liftoff.
And that we're close to finding life in our own solar system.
We're really moving rapidly in our search for life. We're very close to finding solid evidence for life on Mars and perhaps other planets in the universe. This is happening a lot more rapidly than I think people understand. Could be 2 decades or 3 decades, but it's happening in our lifetimes.
Atmospheric entry on my mark. 5, 4, 3, 2, 1, mark.
The search for extraterrestrial life took a huge leap forward when the NASA space probe Phoenix arrived at Mars in May 2008.
Standing by for reacquisition by direct to Earth.
Some 300 million kilometers away, mission controllers could only watch as Phoenix began its perilous descent.
60 meters, standing by for touchdown. Touchdown signal detected. Landing sequence initiated.
Phoenix quickly began to analyze Martian soil for water or other evidence it could support life. And it soon made an astonishing find.
We dug the first trench, and as we dug down about only 2 inches, there was a bright white surface area. And of course, scientists being conservative, maybe it's salt. Yeah, the white spot is right here.
But scrapings of the white substance mysteriously disappeared in a few days.
Salt doesn't do that. Rocks don't do that. So we were really sure we had discovered the ice layer.
For the first time ever, a space probe actually touched water on Mars. And on Earth, wherever there's water, there's life. But Mars is very different to Earth.
Mars is a dry, deserted landscape, frigid cold, sub-freezing temperatures, and no appreciable atmosphere. What a hideous place for life.
Under those extreme conditions, life seems impossible. But scientists continue to be astonished by new discoveries of life where it shouldn't exist on Earth.
Some life forms live where there's no sunlight, no oxygen at all. Boiling water, alkalinity, battery acid kind of conditions. Nonetheless, they thrive. And the message these little critters are sending us is loud and clear, that as long as there's liquid water, the actual environmental conditions, the chemistry, the sunlight, the acidity, doesn't really matter.
The tenacity of life on Earth has radically altered our view of where alien life might arise. The discovery of water, along with carbon, methane, and hydrogen on the red planet, means Mars has the building blocks of life. And the controversial Mars meteorite discovered in 1996 reveals structures that may be fossilized microbes. Some scientists suspect that microbes could exist beneath the surface of the red planet today. Probes sent deeper into space, to the moons of the largest planets in the solar system, have revealed other potential life-supporting habitats. Geysers full of water vapor and organic compounds conducive to life have been found on Saturn's moon Enceladus. And something might live in the hydrocarbon oceans of Saturn's moon Titan. But it's one of Jupiter's icy moons that seems most promising of all. Not just for microbes, but larger, more complex creatures. A future mission to the Jovian moon of Europa may carry a sophisticated lander to the icy world revolving around the gas giant. The journey would take several years, but if a probe could be successfully touched down on Europa, many scientists are convinced that great discoveries await below Europa's mysterious markings.
This one's great.
NASA planetary scientist Richard Greenberg is one of those who think we may find life under Europa's icy crust. He analyzed the intriguing images of Europa's surface sent back by the Galileo space probe.
Yeah, the surface was really quite surprising. For one thing, there are hardly any craters on the surface. Europa is about the same size as the Earth's moon, but it looks nothing like it. There are lines all over the place. Great linear features that run for 1,000 miles or more. Almost all of these linear features consist of double ridges. In some places, there are double ridges crisscrossing over double ridges over double ridges. So it was very puzzling when we saw the surface. What were we looking at there? What did all this mean?
Europa's surface is a frigid 160 degrees below zero. It was once thought to be nothing more than a barren ball, a cold, rocky core encased in an icy crust almost 100 kilometers thick. Now, a better understanding of tidal forces has changed all that.
Here on Earth, when we think of tides, we think of the ocean rising and falling against the shoreline. But really what's happening from a planetary perspective is that the entire shape of the Earth is changing. It's elongating and stretching as a result of the pull of the sun and the moon.
The same thing happens to Europa, but on a much larger scale due to Jupiter's enormous mass. The moon is constantly stretched and compressed as it orbits the gas giant. And like a paperclip flexed back and forward, heat is generated in Europa's rocky core.
It's just like when you rub your hands together, the friction between your hands makes them warm. Well, that's what happens inside Europa.
That internal heat is now believed to support a giant ocean beneath Europa's ice. An internal sea twice the size of all of Earth's oceans combined. It could hold life, similar to the microbes and worms discovered on Earth's seafloor that feed off volcanic vents. Vigorous debate over the exact thickness of Europa's ice crust continues. Some still say it's up to 100 kilometers thick. But Richard Greenberg thinks it's much thinner, allowing sunlight to reach the liquid water underneath, providing energy for larger, more complex creatures. He points to double ridge features he says can only be formed by cracks in a thin ice crust.
Europa is sort of like an egg. It's like a raw egg. It's got an ice crust on the surface and liquid below. Well, imagine you changed the shape of an egg every 3.5 days, made it longer and shorter. What's going to happen to the shell? It's going to crack.
If Greenberg is right, when the ice cracks, ocean water is pulled towards the surface where it freezes. When the tidal force recedes, the crack compresses, pushing the frozen slush upwards. As the process repeats, the double ridges form. In the cracks and water below, could we find an ecosystem? Even fish-like creatures?
Tides on Earth produce zones like this tide pool that are particularly rich in diverse life. As the water flows in and out, it delivers nutrients, everything that life needs. Just as tides can support life in a tide pool on Earth, they may well support life in a niche like one of these cracks on Europa.
Experts like Richard Greenberg imagine a future mission to Europa able to penetrate below the icy crust. Perhaps armed with a nuclear-heated camera probe, able to glimpse the exotic marine life that may thrive in the tidal oceans below a barren surface. And if life could evolve in Europa's watery mantle, then somewhere beyond the solar system, intelligent life must also exist. In a couple of decades, more powerful descendants of the Hubble Space Telescope may be able to detect rocky, Earth-like planets around distant stars. New planets are being found around other stars all the time, although most of the hundreds found so far are massive gas giants like Jupiter. Perhaps, in the future, many more smaller Earth-like planets will be found. Sensitive instruments of the future may be able to pinpoint a target around a star the same size as our Sun, a planet roughly the same size and distance from its star, with oceans of liquid water. Such a discovery would confirm that we are not unique. Evidence that many more planets exist with just the right conditions to support life as we know it. Is Earth one of a kind? Or does our universe contain millions of planets that aliens could call home? Until recently, it seemed our Earth was unique. Observations from one of the most powerful Earth-based telescopes at the Keck Observatory in Hawaii is proving otherwise. The first extrasolar planet was discovered in 1994.
What were we at air mass 2 on the last one?
Before that, some astronomers suspected planets were extremely rare.
Wow, we're getting a lot of counts. That's better than last
But
time.
now the count of planets orbiting distant stars is over 400 and growing rapidly.
CCD readout complete.
These coordinates will match those coordinates and will be locked in, and the star should appear here. Whoop, there it is. That's the star. First planet hunting star of the night.
One of the world's leading planet hunters, Jeff Marcy, has discovered more than 100 of the new planets found so far.
Planet hunting is raging on fire right now. There's interest in finding Jupiter-like planets. There's interest in finding planets that orbit stars that are just like our sun. And most importantly, there's a great push to find other Earths. Are Earth-like planets common? Are they rare? Are they a dime a dozen or 1 in a million? We just don't know.
The vast distances involved make finding extrasolar planets extraordinarily difficult. They're far too faint to be seen with standard optical telescopes. But fortunately, they don't have to be seen to be detected. One way to find distant planets is to search for a wobble effect they have on the star they're orbiting.
The most successful technique has been to measure the wobble of the star as it's yanked gravitationally by that planet. And of course, the more massive the planet, the more that star gets yanked around.
The largest planets that tug hardest on their stars are the ones that show up most easily. These are supermassive hot gas giants like Jupiter and Saturn, with poisonous atmospheres unlikely to support life. The places most likely to harbor alien civilizations are smaller, rocky planets with water, similar to Earth.
Engine start. 1-0 and liftoff of the Delta II rocket with Kepler on a search for planets in some way like our own.
Burning our engine. Chamber pressures are building.
When NASA launched the revolutionary new Kepler telescope in March 2009, the hunt for extrasolar planets moved off the ground and into space.
Kepler is capable of detecting Earth-like planets orbiting around tens of thousands up to 100,000 stars.
Kepler orbits the Sun like the Earth. Its single large photometer works like an unblinking eye, staring into a large portion of our Milky Way galaxy. It's looking for distant solar systems with orbital planes orientated edge-on to its detector, so that it can measure the effect of any planets passing in front of a host star.
And here's the way it works. When an Earth-like planet crosses in front of a star, it will block a tiny amount of the starlight. Actually, 1/100th of 1% of the light of the star will be blocked every time the planet crosses in front. And that tells us the size of the planet, the diameter of the planet. Bigger the planet, the more light is blocked. Bingo, we get the size of the planet.
In just a few years, the Kepler mission could determine whether Earth-like planets are rare or common, making the tantalizing possibility of alien life even more likely.
My guess is that 60, 70, 80% of the stars you see in the night sky have rocky planets orbiting them. Maybe some of them are like Mars, maybe some of them Venus, others may well be like the Earth.
New telescopes are finding not just planets, but the building blocks of life. Water, carbon, nitrogen, even complex hydrocarbons in space. Instruments will also be able to measure these elements and compounds in the atmospheres of newly found planets. The discovery of extraterrestrial life may soon be at hand. The most significant discovery for humankind may come from a future space mission using such instruments. Perhaps they will detect a synthetic chemical like chlorofluorocarbonate or CFC. It would mean the alien planet has industrial pollution, a sign of technology. Of course, this scenario and our planet Sigma 547 is just a fiction. But with an increasing number of sophisticated eyes and ears on the sky, many believe such a breakthrough is just a matter of time. In the event of the discovery of an Earth-like planet with evidence of civilization, radio telescopes like the 350-dish Allen array could be used to lock onto the target, searching for alien broadcasts. Broadcasts that would finally confirm that we are not alone in the unimaginably vast universe, of which we are less than a speck of dust. Those who've dedicated their lives to search for alien intelligence claim that the sheer size of the universe makes it highly likely that somewhere out there, another advanced civilization is sending messages into the cosmos.
You can do the numbers, right? There are a couple of 100 billion stars in our Milky Way galaxy, and the chances are that about half of them have planets. So let's say 100 billion stars with planets. How many planets do each of them have? Well, on the order of 10. We have 8. Say 10. So that's 1 trillion planets just in our own Milky Way galaxy.
If just 1 in 10,000 planets develops life, and just 1 in 100,000 of those develops intelligent life, that's still 1,000 societies in our galaxy alone. And the universe contains billions of galaxies.
Aliens should be here for a whole set of reasons. We know that the sorts of stars which allow solar systems to evolve are, in many cases, billions of years older than our solar system. So, in principle, life, evolution, and I would argue intelligence might have a head start of 3 or even 4 billion years.
If they are out there, and they have been around far longer than us, what do scientists think might truly be possible? Could they be trying to contact us? Could we detect and decode a message from aliens? Astronomer Seth Shostak thinks we could hear from aliens in just the next few decades. For many years, he's been the public face of SETI, the Search for Extraterrestrial Intelligence. It's a private organization that's been searching for ET without success for half a century. But a powerful new tool may change that. The $50 million Allen Telescope Array in Northern California. It's the first radio telescope to be dedicated to the search for extraterrestrial signals.
So there are about 42 of these antennas here now. The idea is to actually get this up to a few hundred dishes. They're 20 feet across, which is pretty small compared to other radio antennas, but in fact, because there's so many of them, the total collecting area, the sensitivity, if you will, is very, very high.
When it has its full complement of 350 dishes, the Allen Array will open new doors into radio astronomy. The main dish of each telescope focuses radio waves onto a smaller dish in front. Inside is an amplifier.
Now, the amplifier that's over here is extraordinarily sensitive. In fact, there's some cryogenics here, cooling, to keep it at very low temperature, so it's even more sensitive. It is so sensitive that if somebody were to turn on a cell phone nearby, it'd probably fry the amplifier. So, no cell phones on site.
The array already generates a massive amount of data, almost a gigabyte, or the equivalent of 2 full feature films a second. Such volumes of digital information can't be stored, but must be worked through in real time.
This is kind of the machine room for the telescope. The antennas, of course, are outside. They're sending everything they collect back to this room via fiber optic. Now here what we do is we subsample some of that incoming data. We can't analyze it all. There's just too much. But we sample some small fraction of the radio dial, we combine it, and then we analyze the signals coming out of there, looking for something interesting. What you're looking at here is just the noise of space, cosmic static, a little bit of noise from the receiver. No obvious signal in this. But every now and again, we'll pick up something a little different. And you can see right here a signal very clearly. This is such a strong signal you can see with your eye. It's also visible over here. This, it turns out, is just a satellite. But this is the way a signal would look if it's actually ET's transmitted.
Finding a signal is like tuning into a station on the radio. But after some 50 years of scanning the cosmos, SETI researchers are yet to tune in to ET. In the early days of SETI, that's what astronomers did. Search through frequencies, one star system at a time. Even after 50 years, the search has barely begun.
The problem is we've really only looked at a very small number of star systems over a very narrow range of frequencies. We've just barely scratched the surface looking for ET with this technique. Well, this antenna back here has the capability of searching hundreds, eventually thousands of times faster of anything we've done in the past.
Within 20 years of being fully operational, the Allen Array will be able to search for signals from 1 million stars as far as 1,000 light years away. That's 1,000 times more stars than we've ever searched before. Seth Shostak is confident those numbers mean contact is imminent.
We haven't found any cosmic company yet, but I think that in the next 24 years we're going to pick up a signal that tells us that somebody's out there.
If someday we do detect an alien signal, will we be able to understand it? Even human languages have defied comprehension. People have been trying to decode this Easter Island text for more than 100 years.
I mean, think of the hieroglyphics, right? I mean, all these markings in stone on these walls in Egypt. We didn't understand them for a long time, but we knew that that was a message, that there was some meaning to those marks in the stone. On the other hand, if they're deliberately broadcasting something to Earth, maybe they'll make it really simple for us.
How might an alien civilization construct a message that could be universally understood? We've already sent messages into space using the language of mathematics. In 1974, astronomer Frank Drake used a powerful Arecibo telescope to beam 1,679 laser pulses towards a distant star. That number is the product of 2 prime numbers. If an alien receiver could plot the pulses using those numbers as columns and rows, it would see graphics depicting a human form, our solar system, and even the Earth's population. But when Drake challenged his colleagues to decode the message, every scientist came up with a different interpretation. If we receive an alien message, we may not be able to understand it, but simply receiving one would be a world-changing event.
If the SETI people find a signal, it's going to completely revolutionize everyone's view of their place in the universe.
That would be one of the greatest existential discoveries of science. We'd be part of something so much bigger than is possible on the Earth.
Although we may be sending sophisticated laser signals in a bid to contact ET in the future, We've already been announcing our presence to the cosmos for almost a century. Almost every radio and TV broadcast has escaped into space. Traveling at the speed of light, these weak signals have already reached around 10,000 stars.
100 and 200 meter track gold medals were won by America's great black athlete, Jesse Owens, the fastest man alive.
Some scientists are eager to communicate with aliens. Russian astronomer Alexander Zaitsev has used one of the most powerful radio transmitters in the world to beam radio signals directly at nearby stars. He believes we have a moral obligation to let other civilizations know they are not alone. But taking the first step in any potential relationship is a risk. What if they're not friendly?
There are some people who even think it might be dangerous to tell aliens about whom you know nothing that we're here.
That fear is based on reason. Predators of all kinds are vital to the ecosystem on Earth. Why should it be different anywhere else? What if the aliens are predators and we are the prey?
The terrifying possibility is that the things out there are more like stormtroopers than people who take their children for a walk. And I think that's worth thinking about, because some science fiction has explored these terrible possibilities that the things out there are exceedingly nasty.
Like the invaders in H.G. Wells' War of the Worlds, aliens may look at us the way we regard bacteria. But surely we have nothing to fear. Even if the most predatory aliens detect our signals, it would take them tens of thousands of years to reach us. Or would it? Could aliens really travel here? Although unlikely, it's not impossible. NASA scientist Jeff Landis has been thinking about the technology that advanced aliens might use for a long time. He designs advanced propulsion systems for space travel.
Interstellar travel is tremendously difficult. And the real problem of it is the distances involved are just so immense. If we launched a probe today using chemical propulsion that went as fast as the fastest probes ever sent by humans, it would be tens of thousands of years before they even got an appreciable fraction of the way to the nearest star.
But theoretically, loopholes in the laws of physics could allow more advanced civilizations to travel much faster. According to the theory of relativity, if you could stretch the space-time behind a rocket ship and contract it in front, you could create shortcuts that would allow you to travel at unimaginable speeds.
So far, warp drive is entirely theoretical, and it's not something we know how to do yet.
The laws of physics also make it possible to create another shortcut in space-time, called a wormhole. But making one may require the same amount of energy produced by an entire star.
They're possible in theory, but the question is, how could you make a wormhole? And the answer is we don't know.
If aliens exist and ever make it here, they will have developed something more technically advanced than rockets, which have severe limitations.
Rockets have to carry their fuel on board. And this is what we call an exponential problem, because of course you have to carry fuel, and that's heavy. So you need more fuel to carry your fuel. Then you need more fuel to carry that fuel that carries the fuel. Pretty soon, the rockets get just huge.
But there are alternatives.
Is there some reason you have to carry the fuel with you? What if instead you could beam the energy to you?
That's the idea behind this. a galactic sailing ship powered by light already being prototyped by NASA. The sail would be giant, perhaps 100 meters across, made from mylar, sheets of tough, reflective polyester.
The real solar sail material would be even lighter than this, of course. We need to really minimize mass if we're going to make a spacecraft.
Aliens journeying by light sail wouldn't have to carry fuel. Massive lasers from their home planet would beam power to their ship as it traveled between the stars.
It's certainly something we could imagine being feasible. Something that we could do with technologies that we understand today.
If aliens from the nearest stars to Earth built a light sail, they could reach us in less than 25 years. It's even conceivable they may be able to create a rocket fuel of much greater efficiency, antimatter. Our largest rockets, like the Saturn V, use almost 5,000 tons of fuel to reach orbit. Antimatter fuel would weigh next to nothing in comparison.
The answer is less than a gram of antimatter, less than the weight of a single penny. Pretty powerful stuff.
Although it's poorly understood, antimatter does actually exist. It's even been made at the particle accelerator CERN, where protons are smashed into each other at almost 300,000 kilometers a second. When antimatter combines with matter, it's explosive. Today, it would take about 100 million years to make a single gram. But who knows what technologies lie ahead?
We could certainly imagine alien civilizations that are just a little bit more advanced than us, putting together these antimatter-fueled rockets and moving among the stars, perhaps even coming here.
Current velocity 12,084 miles per hour.
Aliens coming here. It's long been the stuff of science fiction. But some believe it's only a matter of time before humanity has a real close encounter with aliens who may not be so different from us. In theory, almost anything is possible, including intelligent alien life harnessing some kind of space warp technology to make it across unimaginable distances to visit Earth. Although there's no proof of the existence of even the most basic life forms outside our planet, if intelligent alien civilizations do exist, what might they look like? Many scientists think they would look nothing like us at all. Their senses, their locomotion, everything would be different. But paleontologist Simon Conway Morris doesn't agree. Controversially, he believes they'd share many familiar traits with us. The clues are here on Earth.
When we look at the whole diversity of life, it's staggering. Tulips, tapeworms, elephants, sperm whales, fungi, what could be more different? But my argument is that, in fact, there's an underlying structure, if you like, to the tree of life, which makes certain outcomes either very likely or sometimes possibly even inevitable.
Where others see a world of infinite variety, he sees the same, most effective evolutionary features repeating over and over again. It's called convergent evolution.
I look at an octopus, the octopus looks at me. Now we know that the eye of the octopus is remarkably similar to our eye. It's built on a so-called camera design. Something like a camera eye has evolved independently maybe 7 times, and almost without exception, the animals involved are fast-moving, they are predators, and they tend towards intelligence.
It's not just eyes. Wings evolved on birds and on bats, even though they are separated by more than 300 million years of evolution. The extinct Tasmanian tiger looked like a wolf right down to its teeth, but it was a marsupial, a kangaroo in wolf's clothing. Simon Conway Morris believes certain features evolve over and over again because they are the best solutions for living in our world.
Most of the things, in my experience in biology, don't work pretty well. They work fantastically well. For instance, the eye can, in principle, detect a single photon. Our ears can operate at the level of thermal noise. Noses can, in principle, smell a single molecule. And do you realize what that means? It means that we have got to the limits of the visible universe.
If he's right, convergent evolution theory has big implications for all life in the universe.
The argument is really that evolutionary convergence provides, dare one say, a ground plan for life in the galaxy.
His argument goes on to suggest that an Earth-like planet, combined with the same evolutionary timeline, will eventually produce creatures that can walk on two legs, use tools, and become intelligent beings.
But if it's something similar to the Earth, then I'm hard pushed to see why they won't have something awfully like a human. Not exactly the same, because of course it's a completely different evolutionary history. But one gets the sense that all those alien movies where they did look surprisingly humanoid was not a failure of imagination by us, but actually a biological reality.
But the existence of aliens remains a philosophical question.
It's common as astronomers when we're observing here to go out in the middle of the night and just look up at the stars. Every time I do that, I wonder if there's someone on a planet orbiting that star looking back at us.
There's billions and billions of stars. It's hard to believe that some of them don't have life.
Maybe the nearest advanced civilization is hundreds of light years away, maybe thousands of light years away. Surely they're out there.
In the last 30 years, the scientific case for the existence of ET has become much stronger. If we ever meet alien brethren, it may be that they're not so alien after all.
If I'm correct, I would be almost ready to go across and shake them by, do you call this a hand?
Who can tell what awaits us in the future? So far, alien intelligence only exists in science fiction fantasies. Elaborate stories of secret UFO interceptions and alien contacts remain just that, stories without a shred of proof. It's hard to imagine that we're alone in the vast expanse of the infinite universe. But it's those vast distances that will have to be bridged if we're ever to experience the fantastic visions of ET dropping in to check out their celestial neighbors.